it's anything besides 0? And it's not, right? So we're going to plug these numbers in until we get something that is 0. Okay? Then, after we do that, we're going to do synthetic division to divide our polynomial by the root. And whatever's left over, we're going to factor. I'm going to show you an example, and then we'll take a break. So can you stay with me for an example? Yes, we got you, Solver. Okay. Now, have these notes. I mean, it's right above you. I was going to say have them close by, but basically refer to your notes as we're going through. Here's that one that I said, let's find all the roots, and we couldn't factor it. So let's start off doing step 1, which is the rational roots there. We're going to find all possible roots. The way we're going to do that is by taking our constant term, factors of our constant term, and dividing it by factors of our leading coefficient. What is our leading coefficient?
1.
See, it's the number in front of that term, and if it's not showing it, it's 1. Okay? 1's shy, it hides it. Okay. Now, what we're going to do is look at factors of 3. What numbers multiply to give you 3? 1 and 3, good job. And we're going to divide that by factors of 1, which is what? Plus or minus 1. The only numbers that multiply to give you 1 are 1, right? So let's take those factors here. We're going to have plus or minus 1 and 3 divided by plus or minus 1. Now, what happens when you divide something by 1? Stays the same, right? So, our possible rational roots here are plus or minus 1 or 3. Okay, now, looking at this, guys, how many total suspects do we have? Think of this like Law and Order criminal. It's not 2,
4.
It's 4 because we have plus or minus. So, I have 4 possible roots. Look at this polynomial. How many total roots are we going to have? You're going to have 3. That's what your exponent is. So I know that there are 3 roots. And I need to find all 3. Well, I have 4 options. Is that pretty good odds I'm going to find one?
Yeah.
Okay, so what we're going to do is we're going to choose one, and we're going to plug it into f of x, and what do we hope to find? A 0. What number should we start with?
3.
Now, why would you start with 3? Do the easier one.
I don't know. I feel
Yeah,
like
you
3's
would.
the right one.
You could be right, but you could call me Justin Timberlake, because I've got this feeling the number 1 is going to work, okay? See what I did there? All right. We're going to plug in 1, and let's see what happens. So number 2, this is where we're going to use the remainder theorem. And I'm going to put a little note. I'm going to test 1. What I mean by that is I'm going to plug it in, and again, I'm going to hope for 0. So I'm going to plug in, anywhere I see an x, I'm going to get 1. We have 1 cubed plus 1 squared minus 5 times 1 plus 3.
Minus 5 plus 3. So
Yeah.
8 plus 2.
No.
What? Oh, negative.
Because that's 1
Negative
plus 1
2.
plus 3
Negative 2
is
plus
5.
2. 0.
Minus
It's 0.
5 is 0. Either way, we get 0. Told you I had this feeling, right?
Yeah.
Now, what does that tell us? We've got 2 things going on here. What does that tell us about 1?
It is a root.
1 is a root, which is a fancy way of saying it's an x-intercept. Now, what that also tells us, we've been used to saying it's a factor. Well, remember, I have to put the 1 into parentheses if I want to say it's a factor. So I'm going to do that as x what?
Plus what? Minus 1? Minus 1.
You have to change the sign. Remember, it's opposite. So this would be minus 1 is a factor of f of x. So where are we in this process? We had 4 suspects, we interrogated one of them, and that one is guilty, it's an x-intercept. What is step 3?
You get the, tell us the others.
We're going to find the others using which process?
Division.
Now we're going to go to synthetic division. So I'm going to kind of jump over to here. What we're going to do is we know that x minus 1 is a factor. So we're going to divide f of x by x minus 1 using synthetic division. You're like, so I like long division. I'll say, okay, you can do long division. I'm going to do synthetic. Alright, so let's have a quick refresher on synthetic division. So my root or my x-intercept, that's the number I put up here in the top left. And then what do I write across the top, guys?
Numbers.
The numbers are coefficients. So I have 1x cubed, 1x squared, negative 5x, and 3. What's your question? On the outside. Okay. Mindy, walk me through synthetic division. What do we do here?
You bring down the one.
Okay, you go.
Multiply the ones.
That's 1.
And then you add the ones together.
2.
And then you multiply the 1 and the 2.
2.
And then you add the negative 5 and the 2.
Negative 3.
And then you multiply the 1 and the negative 3.
Negative.
And then you get a 0.
What does that 0 represent, Mindy?
It's a factor.
That's your remainder. Since it's 0, it tells you it's a factor. Guys, we already knew it would give us 0, right? That's what the remainder theorem told us.
Yeah.
But now we want to find the quotient, which this is my constant term, this is my linear term, and this is my quadratic term. So now that I've done synthetic division, what we're going to do is go to our last step, which is step 4, which what are we going to do? We're going to factor. Well, let's write this out first. This is 1x squared plus 2x minus 3. And you guys should know how to factor that, right? We've been doing this enough. I hope you're seeing the process. We're basically saying, I need 2 numbers that multiply to negative 3 and add to 2. Well, the only numbers that multiply to negative 3 are 1 and 3. So I just have to figure out which one's positive, which one's negative, so that it adds to 2.
I told you 3 was a factor.
We didn't say it wrong, maybe. What does that mean our numbers are?
1 and negative 1 and 3.
How do we know it's that instead of the other way around?
Negative 3.
It needs to add to a positive 2 if we switch this side to an negative. So what I'm going to do is I'm going to write that in the parentheses here, x minus 1 and x plus 3.
It's negative.
You're no Justin Timberlake.
I'm not.
Okay.
So there's 2 factors of 1?
Yeah, so let's hurry. Don't jump too far ahead, but this right here.
I'm like all the way in the future.
What does this tell me my x-intercept is?
1.
And this one is?
Negative 3.
Okay, so let's kind of summarize that. My x-intercepts at the very beginning, I got 1. But then at the end, I got 1 again. Can we have it repeated?
Yes. No.
Yes, what do we call that?
It's a bouncing 1.
That's the multiplicity. Remember that? Multiplicity is how many times you use the root. So I'm going to say my x-intercept is 1 with a multiplicity of 2, which if you have an even multiplicity, it means it's going to bounce. What's my other root?
3. Negative 3.
Negative 3. It's only used once. So what is that going to do?
Cross.
And that is how you use our process for finding roots if you can't factor at the beginning.
Why can't we just factor?
Well, how would you factor that? We don't have a method. This is the method.
You put it in the decimals, then you keep writing fractions until you keep writing other equations till the graphs match up.
So this is pretty awesome because it's using a lot of the skills that we've learned. We start off, rational roots theorem. That's something new. Gives us our suspects. Remainder theorem, that's how we test our suspects to see if it's actually a root or not. Once we find one that works, then we use a synthetic division to divide it out. So now what's left over will give us the remaining 2 roots, which we just factor have you check this one. Go on to Desmos, graph it, and what all you're going to do, we haven't graphed this, but what we could do is check, does it bounce at 1, does it cross at -3? If so, then we did it right. So graph that, let's take a break.